What is up, everybody? We are skipping 9.3, going to 9.4, inscribed angles. So, quick review. We know a central angle, his center or has a vertex at the center of the circle. So angle A or angle BAC or angle CAB is a central angle. We also know that the central angle separates part of that entire circle, into an arc BC. We know that the measure of angle A equals the measure of arc BC. So, where do we go from there? We get into inscribed angles. So, an inscribed angle is different than a central angle in that the vertex is on the circle. So, comparing the two different diagrams, look where the location of A is. On the left, A is at the center. On the right, A is on the circle. So an inscribed angle's vertex is on the circle. Also notice now the other sides of the angle, AB and AC, those are no longer radii, those are now just chords. Okay? So that is the difference. Okay? The inscribed angle measure does have a relationship to the arc it creates, however, it's no longer equal. The inscribed angle is half the measure of the arc it creates. So if you are given the arc, you divide it by 2 to get the angle. If you're given the angle, you multiply it by 2 to get the arc. So for example, if this red arc was 120, then this angle measure would be 60. And in reverse, if this was 80, then this arc would be 160. Okay? That is the main takeaway for today. That's the big new concept. All right? So, take a look at this diagram right here. Notice we have 3 different chords. However, we only have 2 inscribed angles. Angle N and angle P. So the question is, what's the measure of angle P and what's the arc measure of PQ? Well, angle P, which is right here, is creating arc MN. Well, arc MN is 70, so therefore angle P is half that amount at 35 degrees. Arc PQ, which is here, is being created by angle N. Angle N is 56, so arc PQ is 56 times 2, 112 degrees. Okay? That's simple, guys. That's simple. Okay, one of the things that people might struggle with is there's a lot of things that starts to happen when a lot of zigzagging, when we start making these inscribed angles, right? There's a lot of crossover and things of that nature. So it's kind of always important to try to be able to separate the information that you're looking at and kind of weed out what you don't need, okay? So let's look at this diagram here. Okay, so I know that the other thing that's important to note is I think that this intersection is not the center of the circle. So notice how there's not a point. So let's do this. Let's put a point right here, just so we don't have that confusion as we're working through this. All right. So the measure of arc CF. So arc CF is right here. So the way that I kind of like to do this is just follow the chords from the endpoints of the arc. So if I go to C, I follow that to D, from F, following that to D as well. So it kind of makes this sectioned off piece. So I know that that 40-degree angle is sectioning off arc CF, right? So then that means that arc CF is going to be double that 40. So it's going to be 80 degrees, all right? Do the same kind of thing for angle C. So I'm going to start at C. I'm going to go out on the rays that are making my angle, and it's ending at D and ending at E. So this arc in purple is the one that's being sectioned off by angle C. In this case, it's 98. So 98 divided by 2, that's going to be 49. So that angle measure is 49. So the arc is double the angle is half the arc. Okay, the angle is always smaller than the arc that it's creating. That's the big thing to remember. And remember, it's either multiply by 2 or divide by 2. All right? So here's another little scenario. Okay, so let's go back and rewind. So I have inscribed angle A creating arc BC. I then have inscribed angle D also creating arc BC. So if two inscribed angles intercept the same arc, so notice how both of those angles are having endpoints at B and C. If that happens, then those two angles, angle D and angle A, are congruent. So angle A and angle D are both creating arc BC, therefore angle A is congruent to angle D. So what we're kind of getting into, guys, is kind of like special scenarios, all right? So that's kind of one special scenario. The next one, notice how we have inscribed angle W. That's the main one we're going to be looking at. And as you follow the rays that are making angle W, where are the endpoints? Well, the endpoints are on a diameter, right? So as it sections off ZYX is a semicircle. A semicircle, we know, has an arc measure of 180 degrees. So if an inscribed angle intercepts or creates a semicircle or has endpoints on a diameter, we know that it's a right angle. Because remember, that yellow arc is 180 degrees. We know the inscribed angle is half the arc it's creating. Half the arc it's creating would be 90, aka a right angle. Okay. Which in turn means that triangle WZX is a right triangle, in case that scenario ever were to pop up, right? Moving on. So here's just a couple example problems, right? So it says find the measure of angle R. Well, in order to find the measure of angle R, we have to solve for X. So as I look at this diagram, I notice that R, if I follow the rays that are making R, have endpoints at Q and T. And then S, if I follow those rays, they also have endpoints at Q and T. So both of those inscribed angles are sectioning off arc QT, this blue arc right here, which in turn means that those angles are equal. If those angles are equal, then the equations that represent those angles are equal as well. So we would set 12x minus 13 equal to 9x plus 2, subtract the 9x, add the 13, get 3x equals 15, so x equals 5. And they're asking for the measure of angle R, so I would take that 5, I would plug it back in there. 12 times 5 is 60. 60 minus 13 is 47 degrees. And then since we knew it was 47, we technically could then find the measure of the blue arc that it's sectioning off, right? Let's look at another one, okay? So notice we're kind of using the previous slides' diagrams. So notice that inscribed angle G has endpoints at F and H. Well, F and H are on a diameter, which means that this right here is a semicircle, which means that that arc is 180, which means that this right here, angle G, is a right angle, 90 degrees. Well, if that angle is 90 degrees, then I know that these two angles in red and in green have to add to 90 as well, because we know that all three angles of a triangle have to add to 180 degrees. So I can do 4x plus 2 plus 9x minus 3 equals 90. Again, because we already had that 90 degree right there, the other two red and green angles have to add to 90 degrees because all three add to 180. Combine like terms, so I get 13x minus 1 equals 90. Add the 1 to both sides, 13x equals 91. Then I can just do 91 divided by 13, x equals 7. So they're asking us for the measure of angle F. The equation for F is right here. So I can just do 4 times 7 plus 2. 4 times 7 is 28. 28 plus 2 is 30. So the measure of angle F is 30 degrees. One more slide. Okay, last specific concept here. All right, now this one involves having a quadrilateral, so a quadrilateral inscribed in a circle. So what that means is each vertex of the quadrilateral is on the circle, right? So we have 1, 2, 3, 4 inscribed angles. Okay. Now we look at this in pairs. So notice that if I were to focus at angle L and follow its rays, it's sectioning off KNM. So this part of the circle. Then if I look at the angle across is N and I follow its rays, it's sectioning off KLM. So together, L and N, as you follow their rays, they're sectioning off the entire circle, which means that the purple arc plus the yellow arc equals 360 degrees. That then means that whatever angle L is plus angle N has to equal 180, because 180 is half of 360. Now they're not equal, right? They would be equal if it was a square, but they're not equal, they are just supplementary. So if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. And the reason we know that is, again, the yellow arc and the purple arc together are making a 360 degree arc. So that means the yellow angle, angle L, and the purple angle, angle N, have to be supplementary, because 360 divided by 2 is 180, right? And we know that inscribed angles are half the arc measure, right? And then the same would be true for K and M, right? If I were to kind of do the same type of drawing that I did for the yellow and the purple, you would see the same thing. So if we looked at this diagram right here, okay, it's kind of hard to tell, but angle Z is opposite angle X, so 180 minus 60 would be 120 degrees. And then angle Y is opposite of angle M. So in this case, 180 minus 95 is 85 degrees. Okay? That's all we got. Okay? Pretty straightforward lesson for the day. Good luck.